Hello, everyone. Thank you for joining us today. My name is Scott Ali. I'm with Intel Public Sector. Really appreciate you joining us today. Love to welcome you to today's program, How to Build Your Resilient Edge, hosted by Intel. And we're lucky to be joined by our customer folks from Mercury Systems. And together, we will share some strategies and some innovative new technologies that can really help public sector IT and OT professionals speed deployment of edge-ready infrastructure that is built to last. So now I'd like to introduce our speakers. So leading off today will be my colleague, John Brindleson, who's a Business Development Manager for Public Sector. He's in our IoT group, and he's going to be joined by Dr. Ian Dunn, who leads the Global Tech Roadmap and Advanced Technology Group at Mercury Systems. So, gentlemen, thanks for joining us today. John, I'm going to hand the virtual mic over to you now.
Excellent. All right. Well, again, thank you very much. And as Scott mentioned, my name is John Brindleson, and I am part of Intel's Internet of Things group, which is a business unit within Intel that focuses on edge-based computing. And really pleased to speak with the folks today listening in here in the audience. And I'll go ahead and get started. There we go. So it's our notices and disclaimers that you have up. And as Scott mentioned, we are going to be going through first quick overview of how Intel is addressing the edge-based computing. I'll hand it off to Ian Dunn with Mercury Systems to talk a little bit about how they help customers implement edge-based compute solutions, and then we're going to open up for Q&A. So as we at Intel, this is our purpose, is really creating a world-changing technology that enriches the lives of every person on Earth. Intel is applying our reach and our scale and resources to deliver on these bold goals, and we're not doing it alone. We work with many of our partners and customers to help create solutions that build upon Intel products and provide even more impact. And with Intel, our customers are helping make roads safer, combating climate change, making healthcare more accessible, and many other end use cases as we expand into this new world. One key thing with Intel is we are in the midst of this transformation beyond a PC-centric company, really to address the needs of the new data-centric world. We've expanded our product offerings to provide this end-to-end solution, scaling from the IoT devices and edge computing all the way up to the network and the cloud. And in addition, Intel is focusing our products to really better address some of the emerging fields and AI analytics, artificial intelligence analytics, as well as autonomous driving. And as we have there at the bottom, it's really our global ecosystem of partners to help deliver those products and solutions to help our customers solve their problems. And one of the key things that wanted to bring up is this. We believe this unprocessed data is really an untapped potential, and one of some interesting statistics is as we look at the number of devices that are connected to the internet, including machines and sensors and cameras that really make up this Internet of Things, it is really growing at a very steady pace. A new forecast that we've shared with folks from International Data Corporation estimates that there'll be about 41 billion connected devices generating 79 zettabytes of data by the year 2025. And this is, zettabyte, of course, is 79 followed by 21 zeros. So it's a large amount of data that is being created. And another key trend is that we see 50% of that data is going to be created and processed outside of the data center or the cloud. And one of the key characteristics with all this flood of data is it's really going to be enabling new technologies, machine learning, natural language, artificial intelligence, but yet at the same time, is also opening up some new challenges. And one of the key things I'll hit on a little later is that to protect this sensitive information, security has to be a critical foundation of these devices that are out on the edge. So as mentioned previously, we believe we're very uniquely positioned to power the computing in this increasingly data-rich world. Our end-to-end platform really optimizes that flow of the bits of data from the edge all the way to the network to the data center. But really today we're here to talk about this, the left-hand side of the screen, what Intel products are doing to support this edge-based computing. One of the key characteristics is, customers want to be able to collect and aggregate and analyze and respond to the sensor data, in many cases before it's transmitted to the cloud or the data center. And Intel's products are not only providing this high performance computing capabilities, but we're also providing a lot of the features needed for systems to survive and last in these edge-based computing environments. A lot of these environments are not pristine, secure, climate-controlled environments, so there are certain things that we want to be able to address to help in that area. And the other key item in this edge-based computing is really to allow customers to take advantage of the intelligence that is coming out of the data through all these, vast amount of IoT devices. Our Intel Silicon is enabling deep learning frameworks through our integration of AI acceleration capabilities. And these are capabilities that we're actually building directly into Intel products. A great example is Intel's Deep Learning Boost, DL Boost. And in addition, we're developing our portfolio of standalone accelerators and software tools to really allow these our silicon products to be easier for developers to deploy AI frameworks, artificial intelligence frameworks. So let's take a look at some of the key features at the Resilient Edge. And these three things that are up on the screen, we really see as table stakes. As we look at the kinds of environments that these edge-based products are going into, as I mentioned previously, they're not environmentally controlled. In many cases, not going into environmentally controlled situations, or they'll see a range of use cases. Many of these devices, unlike your PC or other classic areas where you might see Intel Silicon, these are devices that are going to be running continuously, 100% active. They have very stringent reliability requirements. And so many of Intel's SKUs, a number of Intel SKUs have these industrial use conditions where we've been validated those products to operate up to 10 years and run 100% active 24/7. And then another key characteristic is extended temperature support. So as I mentioned earlier, these are products that are going into, in many cases, field conditions that will see a range of temperatures and will not be ambient 70 degrees all the time. And so enabling that on some of our SKUs is another key characteristic that we see as a need for this Resilient Edge. And then the last item to bring up is long life cycles. So, many of these edge-based solutions that are being deployed may have very long validation and qualification cycles, as well as long sustainment cycles. So I know many customers get frustrated when they go through a 2 or a 3-year qualification and validation cycle, and about the time they're going to deploy their product, and get it ready for production, devices start going into life. So a lot of a number of our products that Intel is developing for these edge-based applications are on our long life roadmap, which means that they're available up to 15 years. There are some products that are still in this 7-year availability, but new products going forward are really being made available to customers for up to 15 years to support these long life cycles, the qualification, those sustainment cycles. So these are the three kind of basic items that we feel are a must-have. And then the others are really looking at security. I had mentioned earlier that these, the environments that edge-based products are in may make them more susceptible to tampering or to even cyber threats. And so we at Intel like to start with what we see as our hardware-enabled security technologies. And these are technologies that Intel designs into our silicon and that our partners can use and leverage to add their own expertise and intellectual property to really give a very hardened product to our end-use customers. And some examples that I wanted to bring up today include Software Guard Extension, SGX, which provides trusted enclaves to run your applications within. Total memory encryption, Converged Boot Guard, and TXT, which enables trusted and verified boot. There's encryption technologies like Intel's advanced encryption standards that help accelerate your encryption of your data, protecting it while it's at rest as well as in transit. And platform firmware resilience is another technology that is protecting your firmware during boot and runtime attacks. And these are, again, like I said, technologies that Intel's designed into our hardware that our partners can take advantage of to really give a more robust solution. So security is one of the key features that we believe is a must-have for these edge-based compute platforms. And then another item that I wanted to bring up as a must-have for the resilient edge is the ability to run these AI models and frameworks. So all these devices are collecting a lot of data, and much of the sensor data today is really going to waste because either we can't process the data fast enough at the edge, or we don't have the network bandwidth to take care of all this data coming in, and in many cases it's resulting in missed mission objectives. So some of the capabilities that Intel is enabling within our silicon, as I mentioned earlier, the Intel DL Boost that we've built into our products. We have a variety of software products. OpenVINO is another example of a software tool that enables users to optimize their AI frameworks to run in these edge-based applications after they've been trained. And combined, a DL framework provides a very significant performance boost. And this is just using your off-the-shelf compute solutions. And in many cases, you can use these off-the-shelf devices and avoid the unnecessary cost of having to add additional GPU cards or even the risk of having to break service or warranty agreements. So we believe that this ability to run these AI frameworks at the edge is another very key characteristic. And then the last item that I really want to mention to the audience is Intel's alliance of partners. We see this as one of our biggest strengths as a silicon manufacturer. So we develop these ingredients. We have our partners, both hardware and software partners, that are designing and developing systems, and then working with different system integrators or federal contractors, working on these end solutions, and really allowing the end customer to benefit as we develop these solutions and systems that help enrich those lives of every person on Earth. And as our next guest comes on here, Mercury Systems, where they fit within this, our Intel ecosystem, developing those systems and solutions for those end users. And as I depart here, just to leave a little bit of some extra information here, please visit intel.com/public sector. We have some great information on government technologies. And also on that page, and there's a link here, we can receive Intel's government technology newsletter, which we can push out to customers as well.
And thank you. Let these slides come up. I think they're up there. That's good. Okay, I'll put it in slide mode. So appreciate the opportunity to speak to all of you today, and looking forward to hearing your questions. So just again, my name is Ian Dunn. I'm a vice president for Mercury Systems and the company's chief scientist in charge of advanced development activity within the company. Mercury is not only a customer of Intel, but also a tier 2 aerospace and defense company. We pride ourselves kind of being on uniquely positioned between high tech and defense, and I'll talk a little bit more about how we use Intel's technologies in bridging that gap. So as a company, we're focused on mission critical electronics, the electronics increasingly involved in making decisions at machine speeds when the stakes are high and nothing can be compromised. At this important intersection between high tech and defense, developing products and solutions for our customers all starts with a culture and practice of trust, which you'll see written on this slide here. Trust to forge the resilient results our customers are looking for in their electronics. And that trust extends to our partners. And you know, some of the things that Intel already mentioned here on this talk, the 41 billion devices, you can imagine how important trust is to this future of the distributed edge. Not only the systems, how they operate, but the data that they produce. At this important intersection, it all starts with that trusted culture that underlines the company's objectives. And as I said, Intel is an important part of that. Trust is not something you can invent piecemeal. You can put together piecemeal. It requires a coherent investment up front, up and down the value chain and across the network of partners, especially when time to market for these critical technologies is a matter of the mission. Trust is not an overlay either. Key building blocks need to be incorporated into components, modules, and subsystems as part of an overall architecture, and this is what we're investing in with Intel to make the resilient edge a reality. Big data is not a new phenomenon, popular term these days, as all of you know, but the process of capturing data, exploiting it for the purpose, continues to evolve at a dizzying rate. John mentioned a couple of statistics. You can see it here, a couple on this page. I can remember not too long ago when the word peta was already an incomprehensible concept. We've moved on to zettabytes, and soon we'll have yottabytes. In computing, the most important efficiency tool in dealing with these big challenges is typically locality, right? Which is a very hard topic nowadays to comprehend when you think of the cloud and all the changes that are going on. On the flip side of it, the most important scalability tool is distributing all of that data and all of that work around the world to these data centers. And when you bring the two concepts together, you get the challenges that we're talking about here on this webinar today. And in particular, the problem of migrating applications back and forth across these two domains with the data of interest. The resilient edge is about consistently exploiting the benefits of locality at the edge for making decisions at machine speed while squeezing as much scalability into the edge as possible. And that's something that Intel has been almost a decade-long partner in developing our strategy in this area that we'll talk about a little bit more. So Intel is a huge partner in this endeavor, as I've said. We've been working with them for a long time on this, and our objective really has been to move these data center technologies that Intel has amassed in its portfolio out to the edge of our customers' network, what we often refer to as the tactical edge. You can see here on this picture that, you know, if we all had a magic wand, the objective would be to take that data center, kind of shrink it for every one of the applications as you move across the spectrum on the right. So you can imagine putting a data center in a UAV, in an airplane, in an underwater vehicle, in a ground vehicle, on a ship. And the objective has to be that once you've done that, that you've delivered a safe and secure capability to that platform. And as we'll talk about a little bit later, and you may ask some questions around this, particularly since sometimes connectivity is always not an assured thing in these migrations to the edge of any network. To create this seamless, trusted enterprise architecture, Mercury has defined 6 areas of innovative investments to bridge the gap between high-tech and defense. And in particular, I've highlighted 3 areas on this slide: security, SWaP, and software. And they're aligned very much with what John already talked about in the Intel presentation. Let me start off with SWaP. SWaP is a surrogate for locality. To get processing as close as possible to the data, you need to shrink it and put it in whatever space is still available in the platform for that function. Unfortunately, SWaP is not an attribute widely associated with today's data centers. You just look at them, they're fun to look at, but they are quite substantial in size. To bring data center technologies from Intel to the resilient edge, Mercury uses a combination of open thermal, mechanical, and electrical standards that are architected to support data center connectivity in a very small footprint. Whatever field you're in, there probably are some standards that you can leverage. We have listed here on this page a number of standards from the defense community, but these are standards about moving data center architecture and components and technologies into a SWaP-constrained environment. Couple this with Mercury's design and manufacturing practices for mobile, rugged environments, leveraging some of the things John talked about in thermal capability, resiliency, reliability. And the result is data centers that can fly, float, drive in some of the most challenging environments on the planet. When John talked about, the extended temperature, we build products that actually use the entire extended temperature over and over again. So it's a very important element of our relationship with Intel. The result is that these systems are ready to host, cloud-native applications, right? These are data center capable platforms with all the software and capabilities in such a way that the cloud and the edge can interact seamlessly. We built an Intel server as an example that fits into the space smaller than 500 sheets of office paper and can scale into hundreds of nodes per platform. It's kind of the flagship of our offering around Intel technology. And it's also the heart and center of our processing strategy at Mercury. Next up is software. When we use the word software at our position in the value chain, like what John said, it's really about integrating hardware and people's capabilities into a sustained package. And we believe this is an important role in the migration from cloud to edge as well, as applications now want to be designed in the cloud and migrate out to the edge. This software platform has grown up to create that seamless operating capability as well. Like what I said with SWaP, it's important to use a set of open standards and open architectures to facilitate this because it creates speed, lowers risk for your customers, and also allows for kind of seamless portability between operating environments. So it's something that we take very seriously when we mix and match our software offerings to create that solution for you. The third one is security, and the last one I'll talk about here. So the investment in security is fundamentally about protecting the data. You can imagine in a trusted edge environment, if you don't have a secure substrate to start with, in many ways, this brave new future of 41 billion devices and zettabytes of data would create quite a headache for many of us because you couldn't be assured that the information you're getting and the capabilities that you've deployed are actually trustworthy. And this is something that Intel takes very seriously. And then at Mercury, we build on this capability from our suppliers to create the overall trust in the platform. And that extends not only all the way out to the edge in the operational environment, but the whole supply chain is important. And that's something that Intel has helped us with as well. So from development, from the engineering code and the firmware, all the way up through the full rate production of the program, that trust is a common element, common thread that governs the whole process makes this edge computing an assured asset for our customers. I'll finish here just with oops, I skipped one. I'm sorry. I'll finish here with just a few comments about. Oh no, I did skip one. Sorry. Yeah. Oh, darn it. I'll finish here with just a few comments about the cloud to edge and this spectrum of materials here that you see here. So on the bottom is kind of Mercury's offering. A lot of that is all based around the Intel architectures that John brought up, and we use the Intel portfolio to move across the spectrum from the cloud all the way to the edge of our application environment for our customers. The two of us have this platform to make this happen. We're proud to deliver it to all of our customers. And you know, as you develop your questions here at the end of this webinar, you know, if you have any interest in how to put this together or unique challenges that you may be facing in the process of deploying to the edge, don't hesitate to ask. Lastly, like John, I'll point you at a web. We have some resources on our web that you can go to. The link here in this presentation, you can follow it. We've built a couple of areas of interest, including around artificial intelligence, which of course is one of the hot topics of the new edge deployment. And if you have interest in that, please follow this link to our area, and don't hesitate to give us a call if you run into any questions or challenges you'd like us to ask. With that, I'll turn it back over to the moderator, Scott, and thank you for your time.
Thank you, Ian. Appreciate that. Hey, we're gonna talk. As we're having kind of this discussion, feel free to go there and add questions. There was one that came in. The gentleman who had asked about the circuit board that can scale video images. We heard the question. We're going to have to do a little digging, but give us a chance to do some digging, and we'll reach out to you directly if that's okay. So we'll get that information to you and a contact, and you can continue the discussion there. So we'll appreciate that question. Had a few more come in here.
Scott, just one thing on that, by the way.
Yeah.
Video, just so the person who asked, video analytics is a huge topic for this industry. I know Intel has a very substantial portfolio in this area, depending on what you're trying to do. But I want to say more generally that managing imagery, video imagery, is something that we do for our customers, whether that's switching it around and distributing on a platform, whether that's symbology overlay, whether that symbology overlay in a safe, secure environment comes up. On the Intel side, that can be whether that's used for autonomy or for detection. It is a huge portion of these edge architectures, and so please do engage us on that. There's a rich portfolio of capabilities there.
Yeah, and thanks, Ian. That's 100% agree.
All right, so let me just throw out some questions, and we'll open it up to both of our speakers here. First, what are some of the top use case applications for resilient edge? Maybe Ian, you can kind of give us your thoughts, and John can chime in.
Yeah, so put simply, kind of in public terms, we all understand it's kind of about that industrial edge, right? We're talking about really machines that are in charge of some level of operation of something. And so the resilient edge is to make sure that those machines do their job securely and safely. Let me give you a couple of examples that are near and dear to all of our hearts. Amazon and some of the other big delivery-based companies in the world are talking about these drones that will deliver packages to our doorstep, or another one that's out there now, right, is the urban air mobility, these kind of urban air taxis. These are edge devices, right? They're connected to large supply chain systems. They navigate on their own if they have to. They avoid making mistakes. They're doing a task of some sort, delivering people or a person. This is on the frontier of the edge. These are some of the most interesting and important tasks in our purview. If you take that over to our domain, kind of military and aerospace, a lot of this is about mobile machines that are picking up wounded, delivering equipment and supplies to the front, maybe engaging in national security activities at the frontier of the tactical edge. That's what that's why the resiliency element is so important. It's either about not hurting someone or safeguarding someone's life or accomplishing a task. If you sent a machine out to accomplish a task and it was less than resilient, imagine the set of decisions you'd have to make differently. So the resilient edge is really about those industrial devices that are out there in healthcare, military and aerospace, all of those things that are out there that are interacting with humans and accomplishing tasks, either crunching data or actually performing physical activities. And that's what we need the resilient edge for.
Yeah. I would add on to that, getting specifics, one kind of key use case is, computer vision. Actually, one of the questions about processing video, that is definitely, one of the things of the amount of video collection devices that are in even a city environment that is being used today is expanding greatly, and being able to do something with that video. There are all sorts of very interesting things that are being done to applied intelligence to that, like here we are in the world of COVID and distancing, and there's all sorts of very interesting algorithms that are being created in that. So that's one key area. And then another very interesting one is audio and translation. That is there's a lot of products that are being developed to address all the microphones that are out today. So and to me, one of the other very interesting use cases is they call it scene intelligence, where you're using multiple sensors, not only video, but also LiDAR, and to really, develop what the environment is that is being looked at, and where, what's the position of folks in there. Like in a military sense, it's been done for like a smart battlefield, where everybody is in this field, and it's using all sorts of sensors and bringing that information together. And again, that's stuff that is really being done in these edge-based environments. So that's just a few. I mean, it's really, there are such a wide variety of these different use cases.
John, I'll add to that because it's a good story for all of you to remember. But one of the use cases that John brought up is voice recognition, and one of the areas of interest is in cockpits. The number of buttons that can be installed safely on a platform is either fixed because it's in the middle of its life cycle, or just hard because they've run out of real estate. So they now want these machines to interact with pilots and operators through voice. So if you think about it, imagine you're out of buttons. You can add more functionality to the aircraft or the platform by having voice recognition as part of the platform. And if you think of the cars we drive nowadays, right? Hopefully you're driving a car with maybe less buttons than it had 10 years ago. But even if you're not, it probably doesn't have too many more, because there's a limit to what we can do. And now they use voice commands. And because of the complexity of that, that's considered an edge to cloud task, right? Because it may have to interrogate the cloud to figure out what you're saying.
Very good. Thank you, gentlemen. Ian, one came in for you based on just a comment you made a moment ago. When you talk about being resilient, do you take into consideration EMP threats and harden the equipment accordingly? Good question.
It is taken into account. It usually requires, it kind of spans the gamut as what you can do with that. That either is special device selection sometimes, or even some or deratings, or even some special things you can do in the architecture to mitigate the impact of that. But whether you're talking about kind of more telecom-centric problems, power outages, earthquakes, fire, all the way to electromagnetic threats that are either at the national security level or otherwise, you can do. That's usually there are elements of the architectural characteristics of the system and component selection you can do to make it have an impact on that. Some cases may require buying a special device in a key area of the architecture as well. But it is something that we engage our suppliers on, Intel, is no different than that on that need occasionally, and engage their specialists sometimes in helping us design systems that can do that.
Very good, thank you, Ian. Another question's come in. When the data center isn't accessible, how does edge computing address big data and AI processing applications?
Well, I'll start with that because that's a big topic in forward deployed edge. The main thing there that people do is to take a bit of the cloud with you, right? So you can think of this as a lot of the software architectures have these caching modes, and so what you want your edge to be capable of is to cache some of the cloud's capability to remove the jitter and resiliency issues that you may run into when you run out of communication. And so what we see with our customers is, first and foremost, they architect their interaction with the cloud to be, bursty, sometimes very low bit rate in some conditions, or even absent. And then they put on the edge architecture some of these cloud functions as a surrogate for the cloud not being there. It puts a bit of a special constraints on the edge architecture that it now has to have more cloud-based capability than maybe a normal edge node would have to have. Might have to have more storage, might have to have more processing in the form of data center servers, might have to have more image processing available. Whatever the surrogate capability that you may have to host for a while needs to be brought into memory and into the compute capability of the platform, and that can create some special constraints on how you design the architecture. But it's a very important topic, even in the commercial world. What they typically deal with this by setting up qualities of service around the cloud where critical services are guaranteed to be available at some level. This is something that's being discussed in the 5G domain, where critical services are guaranteed to be available as they get rid of non-critical services to make room for it. So all of these considerations need to be understood and taken into account when you're building designing your edge solution.
Yeah, I mean, and I would just add into that, as you take a lot of those capabilities that Ian was talking about, and that would normally reside in a climate-controlled data center, and putting them closer to your sensors, I think there are a lot of characteristics that have to be designed into your compute box, for example, of things that you wouldn't have to worry about in a data center, you now have to worry about. So, those environmental protections, even things like dust protection and vibration requirements, because those devices will be really being experienced to other environmental constraints that you would not necessarily have. So there are absolutely challenges. It's by no means a slam dunk where you can go procure some, off-the-shelf server and stick it out in the edge and expect it to survive for any extended period of time. In most cases, it can be very difficult. But it is absolutely a trend. I mean, we're seeing it all across the board. Certainly, Mercury provides that capability. Other Intel partners as well to deliver that cloud-based computing at the edge. And that's a big need as we start to see this trend of more edge-based computing, more performance.
Okay. Thank you, gentlemen. Yeah, and actually that answered, I think, kind of the second question that was kind of a follow-up. So I'll skip to, this is kind of a good, kind of unique question. So data center processing, readily accessible for maintenance and upgrading. Is the same true for edge computing?
I'll start with that, I guess, John.
You go for it.
Well, so the bottom line is when you design a system, of course, you have to think about maintenance. And typically, as a company, what we'll do is we will design to a certain level of reliability, and then the maintenance plan is built around that. And all the standards that you use to create that outcome have to then support that. So, we often refer to in our industry, the two-man lift, right? Computers have to be, you have to be able to pick them up with two people and put them on a shelf at a certain height. There's LRU standards for pulling line replaceable units out, very similar to what you saw in telecom. So first order of business is to design your reliability rates and then match your maintainability around that. The second thing that that's going on in the industry, and the car companies are just starting to show off all their power in this area, is the ability to do software updates remotely, right? So the ability to make patches, fixes, even in some cases where you have high reliability is extremely important, you can shut subsystems down that don't work anymore. This is certainly what sometimes they do in space applications and other very high reliability applications, where maybe you actually switch over to a redundant node temporarily until the system is up for maintenance, whenever it is, if it is ever. So those are the kind of capabilities. And then I think the last thing that's an interesting application level view of this is a lot of people are talking now about using the sensors on board things to be part of the whole maintenance system of the platform itself. So, we used to build sensors into our electronic platforms so that the platform knows when things fail and we need to be rebooted, and temperature, some of the things John talked about. Those capabilities are being brought up into higher and higher levels of functionality to do prognostication, to actually do some planning around when things might fail, when they won't, how long they'll last, depending on some of the operating conditions. And instead of it being a dictionary of behavior in the computer itself, just a prescribed reliability, it becomes a real-time, active, adaptive capability of the whole platform. So that's how we create higher and higher levels of reliability at Mercury. Is first design, then that turns into the operating characteristics, and then there's the real-time characteristics of software patches and the platform even playing a role in safeguarding its own behaviors and capabilities.
Yeah, I mean, I the only thing I would add to that is, one of their bigger challenges certainly is that many of these edge-based systems are not connected and are intentionally left unconnected, and that does create an added level of challenges for maintenance and upgrade. Clearly there you have to roll a truck, which can be a challenge. And as Ian mentioned, these remote software upgrades and having some level of secure connection to enable that is a key element if you want to forego the ability to have to send somebody to that node to do the upgrade, which can be expensive. But yeah, it is a challenge for sure. But there are certainly things you can do to address that.
Very good. Thanks, gentlemen. Another question. First, I think we've dove into this area, but are you providing, and open up to both, are you providing data storage at the edge?
Yeah. So Ian, I'll go and start with this one. I mean, absolutely. There's, Intel has a lot of memory products. Intel's Optane technology is really being heavily used in the data center. I think there's some very interesting things that can be done there with this new type of storage technology. And really what, again, it comes down to is, is this edge-based node going to require other kinds of capabilities and features, environmental protections, and that's definitely what I think. Ian, I'll let you talk to that because that is your world, and I know you all do offer products for this edge-based storage.
Yeah, no, again, building on some of the capabilities of Intel's got some really interesting things in very high density storage. The day that, when you say storage, just one thing to keep in mind is most of it now is really active, right? The notion of these big disk arrays are still there, but a lot of the storage now is, really in memory. And so one of the things as a company, along with Intel, that we're focusing on is the deployment of these really dense memory architectures. So it starts off again with the device, how much memory bandwidth does it have, and then how much memory can you put into the architecture along with the processing solution and still hit your thermal constraints. That's probably one of the more interesting trade spaces now, is between the real estate and power consumption associated with memory versus the processing architecture that's there to exploit it and forward, in many cases, the results into services. So we do make storage blades, storage devices, high density storage devices. We leverage some IP and capabilities from Intel using their high-density storage devices in our architectures. And so it's becoming an increasingly important part of our offering. The edge without storage is where we were probably 10, 15 years ago, where it was really just a signal processor, computing things in line and then shoving things into a network interface. Now there's a desire to store it, archive it, tag it, look at it a couple of times, and then provide it up as a data service or information service to downstream consumers.
Very good. Thank you, Ann. Another question that came in, what about multi-core certification, WCET, CAS32, based at Intel and Mercury?
Well, let me start with that one. The multi-core certification, if I'm following the question correctly, maybe for avionics type applications or flight safety type applications, and this is something that Intel has actually been working with Mercury as a partner in this area as well, for flight safety certification. Intel is we've made available our first flight safety evidence package that we're licensing for one of our CPUs, which the intent is that this is a extra data package. It could be made available to customers designing Intel hardware into a avionics requirement, or any kind of requirement that requires like FAA's DO-254 type certification. So that is something that we are making available. There's in fact another presentation here in a week where we'll be talking about what we're doing in the flight safety world. And of course, one of our partners on the hardware side is Mercury Systems, and they have some products as well. Ian, I'll let you talk more about that, or if you have any other thoughts there on the CAS32 certification.
So I think John did a great job of kind of covering what Intel is doing here, and we're very excited about the package of materials and capabilities that Intel has provided to us and working with us on for a number of customers. But I would also say that one of the reasons Mercury is extremely excited about what Intel is doing is because, in contrast to the past, certified architectures of the past were there really to operate human commands in many ways with some level of automation. And as you move into this new frontier where the level of automation grows by leaps and bounds, maybe an order of magnitude more complicated than what was there before, two things change. One is you now need an enormous number of sensors to do this, and typically these sensors produce imagery or can produce information that can be converted into scenes and imagery. That has to be ingested into these architectures in a safe way and then conveyed into our platform automation. And one of the things that Intel is bringing to the table is really that level of high performance that's required, because 10 years ago it was a very reliable microcontroller that did this work. As we move into this new frontier, a reliable microcontroller is still probably, you can think of that as still doing the automation, but a lot of the sensing that's required to make that automation safe, secure, whatever your set of objectives are, Intel will be an incredibly important tool in that future. And so that's why we've pivoted to really working with Intel on this, and are working with a number of launch customers in this area already.
Excellent, thank you. Well, hey, I think we're gonna wrap it up here today. John and Ian, thank you for joining me today, and for everyone who attended on behalf of Intel and Mercury Systems, thanks for tuning in.